Small nuclear reactors. If you haven't heard of them yet, you soon will. These pint-sized power plants are being hailed as the future of nuclear energy, a safer, more flexible, and potentially revolutionary alternative to the enormous reactors we traditionally think of. So what exactly are small nuclear reactors, or SMRs? The term small is a bit relative here. While conventional nuclear reactors can generate over 1,000 megawatts of electricity, enough to power millions of homes, SMRs typically produce less than 300 megawatts. Unlike their massive counterparts, SMRs can be constructed modularly, built in factories and transported to installation sites. Think of them as the IKEA of nuclear reactors, prefabricated components that can be assembled relatively quickly and at a lower cost. This modularity means SMRs don't require the sprawling infrastructure or immense budgets of traditional reactors. They can be placed almost anywhere, near industrial sites, remote communities, or even military bases, making nuclear energy accessible in regions where large plants would be impractical. But SMRs aren't just about convenience. They bring serious safety innovations. Traditional reactors use cooling systems that rely on external power sources and human intervention to prevent overheating, which is why failures, like Fukushima, can spiral into catastrophes. SMRs, however, often utilize passive cooling systems. These systems don't need pumps or electricity. They rely on natural laws like gravity and convection to maintain safe temperatures, even if the plant loses power. This makes them inherently safer and dramatically reduces the risk of a meltdown. Now let's talk versatility. While large reactors are primarily used to generate electricity for the grid, SMRs can adapt to specific needs. They can produce heat for industrial processes, desalinate water, or even power hydrogen production, essential for a greener, more sustainable future. Their flexibility could help solve one of nuclear energy's biggest obstacles, integrating with renewable energy sources like wind and solar. Renewables generate power intermittently, but SMRs can step in when the sun isn't shining or the wind isn't blowing, ensuring a steady, reliable energy supply. Of course, no technology is perfect. SMRs still face hurdles. For one, while they're cheaper than traditional reactors, the development costs are significant. Right now, only a few countries like Canada and the US are investing heavily in SMR projects. And then there's the challenge of nuclear waste. SMRs produce less waste than larger plants, but the question of safe, long-term storage remains unresolved. Still, as the world races to cut carbon emissions and secure reliable energy sources, SMRs are a promising contender. They represent a shift, a move away from the colossal infrastructure of the past toward nimble, adaptable systems that meet the energy demands of the future. So, are small nuclear reactors the key to solving our energy challenges? Only time will tell. But one thing's for sure, they're changing the way we think about nuclear power and bringing us one step closer to a cleaner, more resilient energy grid.